For years, AI has been this abstract thing humming away in some giant data center. You can use it, but you don't own it.
Right, it's always been somewhere else.
But that's changing. We are seeing this fundamental architectural shift. The intelligence is moving from that central cloud right onto the hardware in front of you, your laptop, your phone.
It's a huge move to the edge.
So today, we're doing a deep dive into how that's happening. The convergence of specialized hardware, truly autonomous software, and this whole new data infrastructure that's making it all possible.
That's right. And the sources we've pulled, they paint this really detailed picture. We've got white papers on the new AI PC specs from AMD and Intel, market analysis on agentic AI, and then a look at the infrastructure, specifically vector databases.
And it all creates these massive ripple effects.
Oh, yeah. Seismic shifts in the market for server CPUs and memory.
So our mission today is to give you a clear map of all these moving parts. We need to understand the new hardware and, more importantly, why this shift is happening now, why it's a strategic necessity. Okay, let's unpack this. Let's start with the AI PC. I mean, this is the foundational hardware change.
It's the thing that makes everything else possible.
Exactly. And what defines an AI PC, it's not just a fast CPU anymore. It's the mandatory inclusion of a neural processing unit, an NPU.
Right.
And the market adoption is it's instant. Our sources cite IDC predicting that by 2028, AI PCs will make up almost 94% of global commercial PC shipments.
94%. That's near total market saturation in just a few years. It's staggering.
So why the speed? What's driving it?
It's really the practical demands of running AI efficiently. Your system needs a balanced system on chip and SoC because the tasks are so varied. Think of it like a specialist team.
Okay.
The CPU is your general contractor. It handles the quick, light AI tasks. The GPU is the heavy lifter for the really intense stuff. And then the NPU, it's the quiet, dedicated assistant for background tasks.
Exactly. It just sips power while handling sustained AI offload. It's all about specialization for efficiency.
And these specialists are setting some pretty high new standards. Look at AMD with their Ryzen AI PRO series. They're setting their NPU baseline at a minimum of 50 TOPS.
Tera operations per second.
Right. And crucially, that's higher than Microsoft's Copilot Plus requirement of 40 TOPS. But is that just a new marketing number? Are companies just one-upping each other here?
That's a great question, and the sources really caution against focusing only on TOPS. It can be misleading.
How so?
Because what really matters for performance isn't just one number. It's the holistic system, TOPS, the combined power of the CPU, GPU, and NPU. And even more important for running LLMs on your device is memory.
Memory capacity and speed.
Yes. If your memory is too slow or too small, a huge TOPS number is useless. The chip is just sitting there starved for data. Which brings us directly to memory. The sources mention a huge innovation here, unified memory architecture. AMD's Ryzen AI Max series supports up to 128 gigs of unified RAM. That feels like a breakthrough for workstations.
It is a massive breakthrough. Historically, the CPU, GPU, NPU, they all had their own separate siloed pools of memory.
Right.
This unified design, it lets them all share resources instantly. It's faster, it's more efficient, and it means pros can load and process these huge, complex AI models locally. It speeds up everything.
So you got this specialist team, and now they all share one massive, super fast filing cabinet. But you still need a conductor, right? Something to manage the traffic.
Precisely. The hardware is useless without the software ecosystem. You need that traffic cop. And on Windows, that's Microsoft's DirectML. It intelligently routes AI workloads to the best component for the job in real time.
And the developers get support too.
Oh, absolutely. Intel has its OpenVINO environment, which comes with a model zoo of over 200 pre-trained models. So developers aren't starting from scratch every single time.
Okay, so the hardware is ready. The AI PC architecture is here. But what is it enabling that we couldn't do before? We have to shift from the chip to the application, to agentic AI. Here's where it gets really interesting.
This shift from traditional generative AI to agentic AI it's foundational.
Explain that difference.
Well, think of traditional generative AI as passive. You use RG retrieval, augmented generation, you give it a prompt, it gives you back text or an image.
It's a response tool.
Exactly. Agentic AI is totally different. It is autonomous and goal-driven.
So what does that look like in practice? Autonomous and goal-driven.
It means the agent can take a complex request and then on its own break that down into smaller subtasks. It can call external tools to get things done, check the results, and even change its strategy if it hits a wall.
So it's not just answering a question, it's solving a multi-step problem.
Precisely. The sources point to early examples like AutoGPT or the developer agent Devin as sort of the first steps in this evolution.
This just completely transforms how we interact with our computers. We're going from this application-driven model where you open an app, do a thing, close the app,
Right, the old
to an intelligent agent-driven model. Your computer stops being a passive tool and becomes more of a proactive colleague. You can just ask it, in plain language, to plan an entire business trip, and it will book the flight, send the calendar invites, reserve the meeting room, all across different apps.
Exactly, and the operating system has to evolve to handle that. The sources talk about two stages. First, an interim operating system agent, which is basically an extension on top of what we have now.
A bridge.
A bridge, yes. But the ultimate goal is the AI deeply enabled operating system, where the agent framework is embedded deep in the system layer. That deep integration is what gives it granular control over resources, much stronger security, and the awareness it needs to coordinate all those complex tasks.
Okay, so if the AI PC is the brain, and the agentic AI is the conscious mind, it needs a memory.
A deep personalized memory, a digital hippocampus. And this is where traditional databases just completely fail and vector databases become non-negotiable.
Right.
Early AI used vector databases as a sort of patch tool for simple static lookups. But agentic AI needs them to be a constant living decision hub.
Let's really contrast these two, because this infrastructure layer is so important and no one talks about it. A traditional database, like MySQL, is great at finding exact matches in structured data.
Right, an exact product ID, a specific name.
So how is a vector database different?
A vector database like Milvus or Zilla's Cloud handles unstructured data, text, images, audio that's been encoded into these high-dimensional vectors. The best analogy is a library.
Okay.
A traditional database is the card catalog. You search for an exact ISBN, you get an exact match. A vector database is like asking the librarian, hey, I need a book that feels like that novel I read last year about family secrets, but I can't remember the title.
So it's about the meaning, the semantic similarity, not just the exact words.
That's it, exactly. And that's how an agent remembers context and makes connections.
So given that an agent needs all this context and memory, what kind of demands does it place on this new database layer? The sources mentioned they were pretty rigid.
Yeah, there are 4 non-negotiable demands that old architectures just can't meet. First is high-frequency read-write. An agent makes dozens of reads and writes for a single task. It's constantly checking its memory, logging its actions.
Way more than a simple search query.
Oh, orders of magnitude more. Second, massive scale. Agent memory is personal. 1,000 users means 1,000 unique memories. That data scales to hundreds of billions of vectors fast.
Oh, that's huge.
Third, cost balance. You can't afford to keep billions of vectors in expensive high-speed RAM. The database has to be smart. It needs to keep the hot data for immediate decisions in memory and move cold, older data to cheaper storage.
And
Multimodality. Agents have to understand the world through voice, images, text. So the database needs to handle all those different vector types and let the agent make connections between them, like connecting a voice note from last week to a photo you took yesterday.
that pulls all these threads together perfectly.
Yeah.
And the sources have this powerful use case that shows why this all matters. Device-native autonomous negotiation agents.
Right, for sensitive financial domains. Insurance, B2B procurement.
And the core conflict has always been convenience versus privacy. Centralized servers are powerful, but you risk exposing really sensitive financial data.
And the system solves that conflict. It runs the entire negotiation exclusively on the user's hardware. Privacy is no longer an afterthought. It is baked into the core design.
The innovations that enable this are just phenomenal. First, what the sources call explainable memory. It uses cryptographic audit trails, Merkle trees linked to a public blockchain, to document the why behind every single decision the agent makes.
And that transparency had an immediate effect. The user studies showed a 27% increase in trust scores when those trails were available.
Wow, 27%.
Yeah, just because people could verify why their agent did what it did. And it added almost no overhead, just 5.2 milliseconds of latency per decision.
So that's trust. But what about performance? You need big models for complex financial planning. How do you run that on a laptop?
They use something called world model distillation. They take a huge 7 billion parameter cloud teacher model and distill its knowledge into a much smaller 500 million parameter on-device student model.
And the results.
A 5.5 times speed up on high-end devices while keeping over 93% of the original model's accuracy. You get the power without the cloud.
And the third piece, which feels like magic, the multi-agent negotiation protocol. It uses zero-knowledge proofs, or ZK snarks. Explain in simple terms what that lets an agent do.
Okay, a zero-knowledge proof is exactly what it sounds like. It is a way to prove a statement is true without revealing the statement itself. So, say your private constraint is you must buy insurance for between $1,000 and $1,200. The ZK snark lets your agent prove to the other agent that their offer fits inside your secret price range without ever revealing what that price range is.
That is the core of the privacy guarantee.
It's the absolute core, and the whole system just works. It achieved an average success rate of 87% in negotiations and was 2.4 times faster than the cloud-only versions.
Privacy and speed. Incredible. And that technical shift, running this kind of AI on device, has sent these massive shockwaves across the entire global tech market.
Absolutely. The server CPU market is being completely transformed. Historically, all the focus was on training models, that brute force GPU-heavy process.
Right.
But now, inference, the daily application of the model, accounts for 70% or more of all AI computing. Suddenly, traditional server CPUs, your AMD EPYCs and Intel Xeons, they are absolutely critical again.
And that demand is putting visible stress on the supply chain. The source data is clear. Server CPU inventories for both AMD and Intel are completely wiped out. And we're looking at price hikes of up to 15%, even with a 25% growth in shipments predicted for 2024. The demand is just overwhelming supply.
But the most dramatic impact is in the memory market. This is the wow number from the sources. An AI server needs 8 to 10 times more memory than a traditional server.
8 to 10 times.
And because of that, AI servers now collectively consume 53% of the entire global monthly memory capacity.
Wow, over half of the world's entire output. So this isn't some theoretical shift. It's hitting supply chains and wallets right now.
It's fueled what the sources are calling a super bull market in storage. The shortage is so intense that DDR5 memory prices have shot up over 300% since September of 2025.
300%. It's a full stack revolution. And the arms race is just getting started. We're already seeing roadmaps for 2026, like NVIDIA's Vera Rubin AI superchip platform and AMD's 2-nanometer EPYC Venice CPUs. So what does this all mean?
You know, what really stands out is this confluence. The AI PC provides the local power, agentic AI demands the autonomy, and vector databases provide the deep personal memory. Together, they're redefining personal computing. They're prioritizing user control, privacy, and speed over mandatory reliance on the cloud.
So the key takeaway for you, listening, is that the race isn't about raw processing power anymore. It's not just about TOPS. It's about architectural integration. It's about blending the hardware, the memory structure, and the cryptographic protocols like zero-knowledge proofs to build systems you can actually trust. Trust is now a technical specification.
So I'll leave you with this thought. We now have autonomous agents running sensitive financial bargaining on our own devices, using cryptographic trails to guarantee trust and privacy. So ask yourself this: how long before we delegate all of our personalized, sensitive transactions, from stock trades to tax filing, to an invisible agent running silently and securely on our own hardware? When you have guaranteed trust and privacy on your device, what are the limits of the autonomy we'll be willing to accept? Something to mull over until our next deep dive.